Okay, so today's notes page is on the average rate of change graphical approach, but we are going to throw in some arithmetic, so you will need your calculator, and we're also going to look at just calculating the average rate of change and also doing word problems, and the way you present the final answer for those two things is different, so pay attention to that. Okay, so the average rate of change, or arc, of a function is the slope of the line that connects 2 points on the function. So you may have you may remember how to find the slope of a line, and that's y2 minus y1 over x2 minus x1, and that's constant because a line, the slope doesn't change no matter where you are on that line. But if you have a curve like this here, if you want to find the average rate of change and you pick these 2 points, then the slope of that line is going to change. If you use this point and this point, the slope would change. So that's why we call this the average rate of change of a function. You can find the average rate of change of a curve. It's just going to change depending on the points that you pick. Okay, so I guess that was supposed to go in the box. So the formula is not going to change. That is the formula for the average rate of change as well. Okay, so the average rate of change from x equals a to x equals b is the slope of the line from a, f of a, and b, f of b. So that's your arc function. And all I did there was, it's okay to memorize it this way, but I'm using function notation here. So this is my input, or x, this is my output, or y. This is my input, or x, this is my output, or y. We'll call that x1, y1, and call that x2, y2. Or you can use function notation. Output minus output over input minus input. Whatever you use, you need to make sure that you remember it's the y's on top of the x's. It's slope is rise over run, you may have learned, and rise sounds like y's. So it's the change in the y's over the change in the x's. People get that backwards because ordered pairs are x, y. Well, the slope formula, or average rate of change formula, is y's over x's, and that little triangle just means change in. Okay, so we have our example here that's already done for us. We want to find the average rate of change between these 2 points. Okay, and so this point you can see is 0, 1, and this point is, looks like 4, 3. Okay, so the y2, the y coordinate of this one minus the y coordinate of that one, y1, over x2 minus x1, that's what they did there, gives you 2/4, and that's a fraction, but it's not reduced, and we always have to reduce our fractions. Okay, so they both are divisible by 2, so that's 1/2. Okay, now listen carefully. I'll say this again when we get to the word problems. This is a nice exact answer. It's not a word problem, so you can leave your answer this way. Okay, if you wanted to call it 0.5, that's okay, because both of these answers are exact. Okay, no word problem, all of our answers are always going to be exact. What do I mean by exact? I didn't have to round that decimal. The decimal terminated. So let's say I have an answer and I get the arc is 1/3 and it's not a word problem. I'm going to count off if you tell me it's 0.33 repeating. We want to get used to using exact answers. And, you know, I've had people in my seated class argue with me about that. But when you get into calculus and you need to figure out what 1/3 times 6 is, would you rather multiply 0.33 repeating times 6 or 1/3 times 6? And if you don't know that that's beneficial, that's just cross cancel, that's just 2, you need to get good with fractions really quickly. So that's our standard. We want exact answers outside of word problems. All right. Okay, so that's our first example. Let's look at this next example. Find the average rate of change of the function shown in the graph below from the point 0, 0 to the point 5, 5. So this is the line that represents those 2 points, and we want to find the average rate of change between those two. So the average rate of change is y2 minus y1 over x2 minus x1. This we'll call x1 y1, this we'll call x2 y2. So y2 would be 5 minus y1 0 over x2 5 minus x1 0. 5 over 5, you have to reduce that. That's 1. Alright, let's try this one. These 2 points here, we want to find the average rate of change of this function here between these 2 points. Okay, so the average rate of change is y2 minus y1 over x2 minus x1. So this is x1, y1. This is x2, y2. So 0.1 minus 2.5 over -1 minus, that minus is part of the formula. This x1 is a -5, so make sure you don't forget that. And when you have a minus and a negative, that becomes just +5. Now you can use your calculator, so this is where I'm going to pick mine up because I definitely want to show you this, and I'll show you the wrong way and the right way. So the wrong way, if you don't have this type of calculator, you might not have this horizontal division key, which is a grouping symbol. So you might think, okay, I can just do 0.1 and then divide minus 2.5 and then sideways division key -1 plus 5. That's going to give you the wrong answer because this is not a grouping symbol, and we know from PEMDAS we're supposed to divide first and then add and subtract, so that will give you the wrong answer. Alright, so if you want to use that sideways division, or if that's the only button you have to make sure that you put parentheses around your numerator and parentheses around your denominator, because then PEMDAS says that you're going to do the parentheses first, you're going to subtract, you're going to add, and then you're going to divide. But the easier way to do this is just use this horizontal grouping symbol, this horizontal division, which is like a grouping symbol. Then you don't have to worry about the parentheses, and you just type in what you see. Also, I'm going to type in, alright, -1 minus. So in this calculator, all calculators really, they have this minus button, but they also have this little button here with this parentheses. This is a negative and that's a minus, and sometimes people use them, get them mixed up, and they get an error. So if you want to do a minus, you have to use that one. It's going to show up just a little bit bigger, and then a negative is a little higher, like that. You should come up with the same thing. Alright, now that's a terminating decimal, so that's a fine answer. Okay, -0.6. But if you want to show the fraction of that, you're going to use the little squiggle. But either one of these answers is perfectly okay, because this is not approximately -0.6. It's exactly -0.6. So I would take either answer. Now, just foreshadowing, I would not want that answer when it's a word problem. Okay, we'll talk about that in a minute. Alright, let's try this one. We want to find the average rate of change between 1, 2, and what is that, 9, 6. Okay, so we'll call this x1, y1, this x2, y2. Arc is y2 minus y1 over x2 minus x1. So y2 would be 6 minus y1 would be 2 over x1. X2 would be 9 minus x1 would be 1. That's 4/8. Can you leave that answer that way? No, you have to reduce it. Both of those divide, 4 divides into both of those, so that reduces to 1/2. Okay. Alright, let's talk a little bit about what average rate of change is. And what it's saying is we're talking about the change in y over the change in x. So it's going to depend on the 2 points, but what we're saying is between 1 and 8, 1 and 9, between 1 and 9, the y's are changing on average. For every 1 change in y, there's 2 units change in x. So it's all about a change. Now we can get the word change out because now we know that this is a positive slope. So between 1 and 9, the y's are increasing every 1 for every 2 increase in x. Okay, so it's the average rate of change where it's the y's and the x's are changing. All right, so it's not a fixed value. It's a rate of change. All right, now that's going to change depending on the different points you said. So I use the word on average because if you were to take a bunch of different points, then that wouldn't be 1/2, it'd be something different. So on average from 1 to 9, the y's are increasing 1 for every 2 increase in x's. Now, having said that, to get ready for word problems, you're not going to have to interpret when it's just skill work, so that answer would be fine. Okay, but when it's a word problem, we want the x change to always be 1. So when it's a word problem, we want to make it a decimal so that there's a 1 there. So this is a change in y, and this is a change in x. The other thing is, remember, x is your input, or your independent variable, and y is your output, or your dependent variable. So that's going to affect the way we interpret. So the way, if this were a word problem, I would say between 1 and 9, for every 1 increase of 1 in the x, it's going to cause a 0.5 increase in the y. Alright, so let's look at a couple of word problems here. Alright, so this is example 1. Suppose you take a car trip and record the distance that you travel every hour. The distance s you have traveled is a function of the time t. So that language, you have to understand functions, is telling you, and this notation is telling you that t is your input. It's like the x, and s is your output. Okay, that's like your y. The output units are miles and the input units are hours. So here's a picture of the graph. This is time in hours. The x is in hours, and the y is in miles. Okay, and then there's a table that you can look at. So we don't have to pick the numbers off the graph. They've already given it to you. Alright, and it says calculate your average rate of change between hour 1 and hour 4. So step 1 would be to write down the ordered pairs. After 1 hour, according to the table, you've gone 50 miles. Okay, and after 4 hours, you've gone 200 miles. Okay, so the average rate of change formula is y2 minus y1 over x2 minus x1. So y2 we'll say is 200, y1 we'll say is 50. x2 would be 4 minus x1 would be 1. Okay, you can use your calculator, but I'm going to say 150 over 3. Now, people that don't listen in the seated class will present that answer, and I will count off a little bit because it's a word problem. And we always want this to be over 1. It also reduces, but sometimes people might forget it reduces. 150 divided by 3 is 50 over 1. So remember, you want it to be over 1. Okay. Alright, now let's talk about units, because next thing is we're going to interpret. So remember what I said the average rate of change was? It's the change in the y over the change in the x. That's what the formula says. So all you're going to do is go pick out the units for y, which is miles. So this is 50 miles over the units for x, which is 1 hour. And dividing, the word in English for dividing is per. So have you heard of miles per hour? Yes. Velocity is an average rate of change. Okay, so the answer is 50 miles per hour, and I'm going to write out the word per because it's not always going to be something familiar, or you could do 50 miles per hour like that. Okay, now how do you interpret the average rate of change? Well, I've broken it down into a template, which means you can use this you can do the same thing every time. Others of you might change the wording a little bit, but just be careful. Okay, so here's how I start. I always want to not use the word arc to interpret the arc. So if you say the arc is, when you're interpreting, you're not interpreting. Okay, so what's going on is, first of all, we have to remember that this average rate of change is going to change depending on the points you pick. So the first thing we have to tell people are what are the x values that we're using. So this is between 1 and 4 hours. Okay, so you always start out with the interval between 1 and 4 hours. The arc, no, not arc. What is the function? The function has a name, right? S of t is in miles. It's a distance function. See right there? So the distance, that's the name of the function that we care about, which is the output, the distance. All right, now, if this is a positive, then it's increasing. Okay, if it's a negative, it's decreasing. So you don't want to use the word change. You have to tell me either increase or decrease. So between 1 and 4 hours, the distance increased by 50 miles. Sometimes people stop there. The distance did not increase by 50 miles. The distance increased by 50 miles per hour. So people forget to write that per hour. Okay, so you may want to stop the tape and try C and D. Okay, so the order pair for 2 hours is 275, and the order pair for 4 hours is 4200, and the average rate of change is y2 minus y1 over x2 minus x1, 200 minus 75 over 4 minus 2, and this time I'm just going to use the calculator to show you that that is okay once you write that down. So horizontal division key, 200 minus 75 over 4 minus 2, and the calculator is giving me 125 over 2. Is that what you want in a word problem? No, you want it over 1, so hit the little squiggle and we get 62.5. Alright, let's figure out what the units are. Remember, y units, so miles, x unit. So 62.5 miles per hour, that is your average rate of change. So when we interpret the average rate of change, we don't use the word average rate of change. Can you tell people to do that? I don't want you to do that. Here's the template. You start out by the interval. You tell me the x coordinates, so between 2 and 4 hours. The arc, no. The name of the function, this is a distance function. The distance, again it's positive, so increased by the number 62.5 and then miles per hour. Now I always forget, you really should put on average at the end, because this is not exact, because it's not constant, it's not a line, it's a curve. So this is only happening on average. Alright, so go ahead and try to find the average rate of change for these two. These are not word problems, so we would want the exact answer. So the arc here, negative 38.4 minus, and that's a negative 12, over, so if you lead with this y2, you have to lead with its partner. So that would be 0 minus, parentheses, negative 4. And then I have a calculator here, right? Once you write it down, you can use this calculator. So horizontal, negative 38.4 minus, parentheses, and negative 12, and then divided by 0. You can put plus 4 if you know that that means plus 4. All right, and that's a terminating decimal, so you could write negative 6.6. I would not count that wrong. You could hit the little squiggle and put negative 33 over 5. I would not count that wrong because it's not a word problem. Okay, and then the second one, arc y2 minus y1 over x2 minus x1. So 3 minus its y coordinate here, 0, over 4 minus 1 gives you 3 over 3, which is 1. Alright, you might want to try this second example for word problems and pause the tape and see if you interpreted it right. Okay, so it says the graph shows the population in a small industrial city from 1950 to 2000. The x variable represents the number of years since 1950. So I'm going to write this down. This is my Math English Dictionary. Years since 1950. This is something we do very often with years. So what this means is that when x is 0, that means the year 1950 when you interpret it. When x is 10, that means the year 1960 when you interpret it. But while we're inside the function, we're going to use the small numbers. All right, and then it says the P stands for population, and up here you can see that P is in thousands. So P is population, but it's times 1,000 when it's time to interpret. So this is a graph of a P of x function. All right. This is, we'll call it a population function. It's a function that, depending on the year since 1950, you'll be able to see the population. Okay, so the math of it is what's the average rate of change between x is 25 and x is 40. Well, you need ordered pairs, so you're going to have to pull ordered pairs off the graph this time. All right, so when x is 25, which is right here, y is 50. Now it's 50,000, but don't put 50,000 in the work. While you're working the numbers, you want to leave the 1,000 off. That's why we do it. All right, when x is 40, y is 40. Okay, so now we're ready to do the average rate of change. y2 minus y1 over x2 minus x1. So if we call this x1, we'll call that y1, x2, y2. So we're going to do 40 minus 50 over, so if I start with that, I have to start with its partner, 40 minus 25. If you don't, you'll get a sign wrong. Okay, so that ends up being, let's use this. I know it's negative 10, but 40 minus 50 over 40 minus 25. Just want to show you what you get. All right, you get this. But this is a word problem. So, do I want you to give me interpret negative 2/3? No, I want you to give me the decimal. So hit the little squiggle. Oh, did I hit the squiggle? I hit the plus. Try again. And now I messed up. There we go. So negative 0.6, and we have to round it. Okay, so that's what I want you to do, because I want this to be over 1. And you can make any number over 1. Now, what are the units on this going to be? Remember, average rate of change, the units are always going to be y units per 1 x unit, because I told you want it to be over 1. So the y units are population, or people, times 1,000. So this really means negative 0.67 thousand people per year. Not year since 1950. The unit is year. Okay, now I don't count off if you do that, but if you wanted to, you could take this answer here and multiply it by 1,000. Okay, so another way to answer this question when you interpret is, I like this answer here for the numerical answer, but when it's in time to interpret, you could call it 666.67 people. Not 1,000 people, because we already put the 1,000 in there, people per year. Alright, so most people are more comfortable with this. Alright, now let's interpret it. Okay, so you can see that on average, the population fell. If it's a negative, we haven't had a negative yet, that means that the population is decreasing. Alright, so let's interpret. So remember how we start? Between. And this says x is 25 and x is 40, but you have to interpret fully everything. So you have to go back here, look at your math English dictionary. X is years since 1950. So what year is that? Well, 1950 plus 25 would be 1975. So don't put between 25 years after 1950, just do the math. Between 1975 and what year would that be? 1950 plus 40 is 1990. The arc? No. What is this function? This function is talking about population. Okay, now we have to decide, is it the word increased or decreased? Well, if it's a negative, the population decreased. Now since we use the word decrease, we're going to lose the negative. 0.67 thousand people. Put a period? No, it's a rate of change per year. So don't forget to write per year. Or you could say, like I said, 666.67 people per year. Notice that I don't mind the decimal. Please don't round up your person. I don't want you to do that. I want you to round it to the hundredths place is usually what we want. So either one, 0.67 thousand people per year or 666.67 people per year.